Okay. Go and open your book to page 218. So this is the first lesson on chapter 4. And this section, you will learn how to use the identities and also learn how to solve the 6 trigonometric ratios. So let's look at some of the identities, and I give you a handout so you have all the identities together. So let's go over each one of these. So the first set is a reciprocal identity. So you can look on your handout. So again, we covered many of this before already, right? So cosecant is 1 over sine, and vice versa, right? Sine is 1 over cosecant, and secant is 1 over cosine, and also cosine is 1 over secant. Tangent is 1 over cotangent, and cotangent is 1 over tangent, and tangent is 1 over cotangent. So you should know this already. Okay, from what I see, I think all of you are really good with this. Okay, tangent is equal to sine over cosine. Okay, remember sine is vertical, or the y. Cosine is horizontal, or the x. And so tangent is the slope. So slope is the y over the x, right? And cotangent is just the reciprocal. Just flip this over. Okay. And what we're going to get to next is that we're going to do the identity for negatives. And so this is kind of a little bit new, but once you understand how they get these, you don't have to memorize these. It's easier if you just go and try to figure it out. Okay. And one thing you have to be very careful is they use x for angle. Okay. So x is not, when you have the rectangular coordinate, you have the x and the y, right? So normally x is for the horizontal, right? But this one, the x is the angle now. Okay. So you got to be careful. So you need to be flexible. So you can use any letter for the angle. You can use x for the angle. You can use y for the angle. Most of the time you use theta, so it's not as confusing. But you need to be flexible. You can use any letter to use as an angle. Again, most of the time you use theta because it's least confusing. But in this case, they use x. Okay, so you got to be flexible with that. So let's go over the identity for negatives. Why is it so? So think about this, right? So you have, again, remember now, we're using x as an angle now. Okay, so here's your x. So now, if you notice the sign of x is right over here. So that's sign of x, right? Everybody see that? Now, if you look at a negative angle, so over here we have the negative x, right? So sine of negative x is this one right over here. I'm color coded for you, okay? So the question you have to ask is, are they the same or the opposite? Well, obviously it's opposite, right? So if they're opposite, then that's how you get this, and that's how you get this. They are opposite, so equal to negative sine of x, because they are opposite of each other. So this equal to negative of that, right? This equal to negative of that. That's where they came from. So you don't have to try to memorize this. You can just sketch it out very quick and see if they're the same or the opposite. If they're opposite, you put a negative in front of it. Okay? So now let's look at cosine. So over here, so you can here's your x. So cosine of x is right over here. Right, that's a cosine of x. And if you draw the next picture, let's go ahead and use the negative x. Okay, so that's the angle. So for cosine of negative x, again remember x is the angle, right? So over here cosine of negative x is right over here, it's horizontal, right? So now if you look, cosine of x is this over here, cosine of negative x is over here. Are they the same or opposite? They're the same, right? So if they're the same, then they're equal. So cosine of negative x equal to cosine of x. So that's where that came from, because they're the same. Okay, now let's look at the tangent. So again, you have the x over here. So tangent of x. Remember, tangent is the slope, right? So tangent of x is over here. and now you go negative x, going this way. So now your tangent of negative x is right over here. Okay, so again, the question you ask yourself is, are they the same or opposite? Well, one is going up, one is going down. Obviously, they're opposite, right? So that's where they get tangent of negative x equal to tangent of x. So if you don't remember, just do a quick picture like that and compare, see if they're the same or opposite. So that's where it came from. Okay. Now let's go to the next one on your handout. So this is a Pythagorean identity. So sine square x plus cosine square x equal to 1. So again, if you look at this over here, so again, here's your angle x, right? So this is going to be sine x over here, and this is cosine x. And we're using the unit circle, right? Remember, in order for this to apply, you have to have a unit circle. So that's that, right? So if you apply the Pythagorean theorem, normally Pythagorean theorem is a squared plus b squared equal to c squared, right? So it's the same thing, right? So here you're going to get, they kind of switch they kind of put this as first. So you're going to have an a over here. So a squared plus b squared equal to c squared, right? And that's where they came from, Pythagorean theorem. Now you have to be careful what you write, okay? So sine square x means sine x times sine x, okay? Whereas sine of x squared means sine of x times x. So they are totally different things. So this one you square the function. This one you square the variable. So they are totally different things. So you have to be careful what how you write. So again, remember, exponent applied to what is immediately before it, right? So what is immediately before the exponent 2? The function. So that's why the function gets squared. Over here, what's before the exponent 2? X, the variable. So the variable gets squared. Okay, so you got to know the difference between. So you have to be very careful how you write them. Okay, so let's go over some examples of how these things work. Okay, how can you apply all this stuff? So I'm going to go to the homework and go over some of the events. So some of this you kind of already know already. You did a lot of this already. Okay, so let's go to page 223 and let's start with number 6. So you have sine of x is equal to square root of 5 over 3, and you have tangent of x equal to negative square root of 5 over 2. Okay, so in this case, actually they make things a bit easier because they give you more information than before. That you already did this the problem already, right? So again, you want to go and narrow down your triangle. So sine is positive. So sine is positive. So you get 2 triangles here. Okay, so this will give you these 2 triangles. Next, you have to use this information. The slope is negative, right? Slope is negative. So you don't even need a number. All you need to do is worry about if it's positive or negative. Right? Remember, we did this before, right? So tangent is negative. So that means this is wrong, right? So this is correct. So now let's go and put numbers in there. It doesn't matter which one you use. So sine is square root of 5 over 3. And so this would be 2, use your Pythagorean theorem, and so this should be negative 2. And you can check, right? See over here, tangent is this over that, so see, it match. See that? So this one gives you more information than is necessary, but that's good. More information makes things very easier, right? So now you have to get the rest of the function, the functions, right? But again, let's get all 6 together. Now they use the x as an angle, right? So you have to use x. We kind of used to theta, but you have to be flexible. So sine is already giving, is square root of 5 over 3. Cosine is negative 2 over 3. Tangent is already giving. Okay, and then you get the other 3. So sine, then you get cosecant. So you flip it over, and you simplify. So you get 3 square root of 5 over 5. Okay, then cosine, you get secant. So you flip it over, you get negative 3 over 2. And cotangent of x, you flip it over, negative 2 over square root of 5. And this will equal to negative 2 square root of 5 over 5. So kind of run out of space over there. So again, we already did a whole bunch of this before, right? So nothing really new. And same thing when you get to 25 through 30, same type of problem, right? So everybody look at 25 through 30, same type. So again, we already did this before. So this is kind of quick review. Okay, the things that is kind of new is like number 11 through 22. Okay, so let's go and do number 12. Start off an easy one. Okay, so you want to simplify. It seems complicated, but it's very simple. Okay, all you have to do is, if you don't know what to do, change everything into sine and cosine. Okay, so secant is what? Secant is 1 over cosine, right? And this would be just cosine. So again, secant is 1 over cosine, and cosine is just cosine, right? And then you cancel out, so answer is equal to 1, and that's it. So again, the key is change everything into sine and cosine. Okay, so now let's go ahead and do number 22. Number 22 is just a basic algebra. So everything is already sine and cosine already, but you have the square and parentheses and all that. So just go and multiply out. So you have cosine square x plus, so you have to multiply these things out. So you have to know your trinomial square, right? So this one square, you get sine square x, and your middle term would be times all this together. So middle term would be 2 sine x, and you square that, you get plus 1. Okay, so again, you got to know how to multiply these. If you don't know a shortcut, write it out twice. You know, you can write down sine x plus 1, sine x plus 1, and you distribute. So multiply, 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 and work it out. Okay, but you should know how to do this. I mean, come on, you guys trigonometry already, right? You have algebra 1, geometry, algebra 2. You should know how to multiply that already. Okay? If you don't, then you are in very bad shape. Okay. Okay, so simple out. Okay, then when you see the square, that you have to remember your Pythagorean identity. That's a very important one. So this and this will equal to 1, right? From here, right? Pythagorean identity. So this is a super important one. Make sure you know that. So that equal to 1. So plus that. So this will equal to 2 sine x plus 2 over sine x plus 1. Right? This is equal to 1 plus 1. That's how I get 2. That's where I get 2 from. And then from here, you can see that the answer is going to be equal to 2. Right? You can factor out the 2. Don't cancel out terms because you know these are terms. So don't cancel out. Factor out the 2. And so this cancel out. So answer is equal to 2. Okay, and that's all you have to do. Okay, so again, if you're not sure what to do, just change everything to sine and cosine and work it out. Okay, let's go to number 44. So you have 1 plus cotangent square y. Now notice right now they use y as an angle, right? So that's why I say you got to be flexible with your angle, right? You can use x, you can use y, you can use theta, you can use a, you can use capital B, you know, you can use whatever. So you got to be flexible. Okay, so you want to simplify. So again, remember what I said, right? Change everything into sine and cosine. So, and because this is going to be, when you change into sine and cosine, it's going to be complex fraction. So I'm going to make this into a fraction, so it'll be 1 over 1 plus cotangent is cosine, okay, over sine, and this is square, right? Okay, so this is this. And then you get cotangent square of y again. So you're going to get cosine square y over sine square y. So you have complex fraction. Now to simplify complex fraction, you need to multiply by common denominator. So common denominator is sine squared. So multiply by sine squared y. Multiply by sine squared y. Right? Again, don't be lazy. Write down your common denominator. And then you get your fraction ready. So this one does not cancel. So when you multiply, you get sine squared y. This one cancel. So you get plus cosine squared y. This one cancel. So you get cosine squared y. And you have to recognize this. Whenever you have square plus square, right away you cannot have to make the connection. That's the Pythagorean identity. So sine squared plus cosine squared is equal to 1. So it becomes 1 over cosine squared y. And 1 over cosine is equal to secant. Okay, and that is your answer. Okay, so you want to simplify as much as you can into one function. So you have to apply, your basic concept, right? So again, convert everything to sine and cosine, and it's complex fraction. You use your algebra knowledge, okay, the skills to multiply by common denominator to go from complex fraction into a simple fraction, and you apply the identity, and you apply a more identity, and you get that. Okay. Okay, so let's go and do some practice.